Now we're going to discuss the set of both real and imaginary numbers together. When you put them together, they form a complex, like an apartment complex has a whole bunch of apartments put together. So we call the set of all reals together with all imaginary numbers the set of complex numbers. And we use this funky looking C to represent the set of all complex numbers. So I just want to remind you, what's the difference between a real number and imaginary number? Real numbers have no i's anywhere in them. They totally are devoid of any imaginary number I. Imaginary numbers have the number I in them. They come in different forms. They come with just purely imaginary numbers that only have I with a factor, or they come with a combination of the real part and the imaginary part. But the main thing to remember is real numbers have absolutely no i's, while imaginary numbers have the imaginary number I in them. Now here's what the set of all complex numbers sort of looks like. This is just a rough representation. What I want you to notice is there's a universe here, and it's the complex universe, so I'll call it C. And I divided it into two pieces. They don't have to be equal. They're not necessarily equal size, but half of these, or part, not half, but part of these numbers are real, and the other part are imaginary numbers. So I use that funny R, that funny I to represent it. So R is the set of all numbers that have no i's at all in them, and they're listed on the top. And then I is a set of imaginary numbers, so they're the set of numbers that have, all of them contain some kind of I in them. So let's look at the examples. For real numbers, you could have like -7, 41/3, the square root of 2, the number pi, the decimal 3.5. Those are just examples of numbers that don't contain the imaginary number I. So those are all real numbers. Now, imaginary numbers have I, like the number I, the number -12i, the number I times 3/4, the number 3 plus 7i, that's an imaginary number, -1/2 plus the square root of 5 times I. You see, every one of those numbers have I contained in them somewhere. So those are all imaginary numbers. Those are not real numbers. Okay, now, any number that lives in that universe is called a complex number. All real numbers are complex, all imaginary are complex. And the most general way that you can write a complex number is in the A plus BI form. And you always should write your answers when they have I in this form. Okay, you don't have to include the zeros, though those aren't necessary. So A plus BI. In this representation, A is called the real part, and B is called the imaginary part. See, A is a real number and B is a real number, but B is called the imaginary part because it's multiplying the imaginary number I. So this is a complex number. It's like an apartment complex. You've got one side A and the other side B times I. It's a complex of two numbers put together. Now, all complex numbers can be written in this form. Let me show you. The purely real number. So think about it. To be purely real is just to be a real number, basically. I call it purely, but it's just a real number because it contains no I. So a real number, or a purely real number, has no i's. An example would be -7. -7 is a real number because it contains no i's. But how would you write that in A plus B times I form? If you wanted to be very formal, you would write -7 plus 0 times I, because there's no I there. Now, what if you had a purely imaginary number? A purely imaginary number has I and nothing added or subtracted to it. An example of a purely imaginary number that has I, of course, with nothing added or subtracted would be like -12i. How would you write that in A plus BI form? 0 plus -12 times I. See, the zeros don't necessarily have to be there, but you understood they could be there. And the last, maybe how about just a general complex number? That's where you have an I and another number added to it. So, for instance, the square root of 3 times I and then -4. Let's just make one up like that. How would you write that in A plus BI form? You would write -4 plus the square root of 3 times I. That's A plus BI form. And that's the most general form of a complex number. So what I want you to notice here is every one of these numbers, the real numbers, the purely imaginary numbers that have nothing added or subtracted to them, and the complex general numbers, they all can be written in A plus BI form. But in the first two cases, part of that's 0. That's why you don't see it. But just to be able to write them in this form reminds you that they are all living in the same universe, the universe of complex numbers. Okay, now, so what we want to say at the end to summarize, that the following are all complex numbers. Real ones. Real numbers are all complex. Any number that has no I is a complex number. Example, -7, square root of 2, pi, all of those are real numbers. Some of them are weird real numbers, like the square root of 2 is a weird number, pi is a weird number. Those are called irrational numbers, and that's another story altogether. But those numbers are definitely, they are complex numbers. Imaginary numbers, any number that has I, and even purely imaginary numbers that have no real part that we talked about, even those are complex numbers. So all of these kinds of numbers are complex numbers. We actually, since we know about real numbers and we know about the number I, we don't know about any other types of numbers besides the numbers that live in the complex universe at this point.